Okay. So, so you can see my screen, right? Yes. Okay. 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 So in the last class, I guess uh, we have did all the assignments from the last run till week 5, right? Week 5, take until this assignment we have done. So there are coding assignments still remaining. And so today our objective will be to and this is actually an extra class. So this is week 13, which is an extra class. Okay, so we'll be finishing the remaining assignments from the previous run. Okay. So okay, you can, if you cannot find the necessary information for your exams, you can find it in the PPT for week 12 and week 13. Okay, I have kept it in both the weeks PPT so that it's easier to find. Okay, so every necessary information is there for the exam is there present in the PPT. Okay, so okay, so yeah, week 5. So you have did all this till now. Okay. Okay. So at this point, I guess we are dealing with like lists and all. Okay. So what is, yeah. Now let's go to the programming assignment. What is the programming assignment? Write a function insert that accepts. Okay, let's just also like do some like basic programs on like on the way. Wait, let me have with 13 and we'll keep the question outside. Okay. So what is the question first? Write a function insert that accepts a list L and it's a sorted list of integers and integer x. Okay, and integer x as input. So there are two inputs. One is a sorted list of integers L and another one is the a particular integer x. Okay. Now the function should return a sorted list with the element x inserted in the right place in the input list. The original list should not be disturbed in the process. Now, now the problem statement is pretty clear, right? Now let's see what are the restrictions. So don't take. So one of the like main thing that you should remember while whenever you are writing code, you should not. Let's say the question is very easy, okay, and you can like think that okay, it's 2-3 lines of code, but don't just start programming at then. Okay, so just read the whole program. There will be restrictions as well. Okay, let's say it is coming from week 5, right? And you don't know some structure like some primitives or some structures at this point. So you are not supposed to use them. Okay, and they would be clearly mentioning these things, these requirements and all. So just be mindful before attempting a question. Okay, so look for requirements and restrictions. Requirements for your program, which should be input, which should be output, these things, how it should be outputted. So because they will be mostly checked by automated checkers, right? Like program checkers. So they're very particular about how the code is being output, like giving output. Okay, so just be mindful about what you are printing. Okay, and like the parameter list of the function, the exact order you should also write in the code. Okay, whichever order they're mentioning in the question. So for this program, the requirements are a list and an integer x, and the like assumption is the list is a sorted list. Okay, now the only built-in methods are allowed to use append and remove. So these are restrictions. So if I just stop here and start coding, then it's very easy, right? I will just use the sort method or something. But the thing is, you can only use append and remove. Okay, you should not use any other method provided for the lists. Fine. You do not have to accept input from the user or print the output to the console. Fine. You just have to write the function definition. So insert function that inserts a number at a correct position. That's it. Okay. And it should return a secondary list. So the primary list should not be have. So see this thing, or the original list should not be disturbed in the process. So what we know that Python lists are basically pointers, right? So whenever you are modifying something, let's say you just create a shallow copy, and I hope you remember what is shallow copy and deep copy, right? So shallow copy means you just copy the reference in another variable, right? So let's say if I am copying reference from A to B, then A, B, both of them points to the same data structure in memory, right? So if you are doing a shallow copy, then if I am modifying B, it would inherently modify A also, right? So in that case, you have to do a deep copy. Okay, and they didn't mention anything about string slice, like sorry, list slicing, right? So you can obviously use them. Good. Okay. So let's just start coding. So a list, let's say 1, 2, 3, 4, 5, or let's say 10, right? And I insert 5 now. So what will be the process? So x should be 5. Now definition insert, right? It expects a list and a integer x. Okay. I'll just like for sake of simplicity, let's just name the variable same. So you can do this thing. Okay. So this name inside the function, whatever you name the variable, they can be same. There will be, so if you don't pass, let's say, so in this case, it will create a global, like local scope for the function L and X, but I can just don't pass them and use them here, L and X. It would also work because by default, the functions take the global context, right? The global scope. Okay. However, let's say if I am defining the variables here, X, L and X, in that case, this is a local scope for the function scope, right? Now it doesn't have access to the global scope. So basically the name binding has been replaced from the local scope. So now in that case, you have to definitely pass it. Okay. Now let's see. So what I can do, I can only use append and remove. I don't think remove use will be used, but anyway. So let's just do in a, and it's already a sorted list for I in range, or let's say not range, let's just do L, right? A capital L, and it's already a sorted list. So before it, I will create another list L modified, right? And just do if X is less than, because it's a sorted, let's say I'm supposing it's an ascending list. So, and did they mention anything about ascending or anyway, ascending, descending, everything would work, obviously. So, okay, so if X is less than, let's just name it E, right? E is for element. So if X is less than element, that means what? That means I have to move, right? So that means I will just add the element as it is. So L modified dot append E. Okay. And else, sorry, x is, let's say x is 5. Okay. So it should be here, placed here. So when 1 comes, 1 is greater than, sorry, so x is greater than E, then we should just add it, right? Whenever it becomes less, so it will it will be less here. So 10, 5 is greater than 10, that would be false. So else first insert x and then insert the element. That's it. So this code still holds, and we will modify it to its code. And then we first insert x first, and then we insert E. Okay. And now we return L modified. Let's test. Insert L comma X. Okay, it's now inserted at the correct place. Okay. Now let's just so it will not work if the string, if the list is in a descending order, something like so. Let's see whether they have mentioned it's ascending or descending. Sorted list, right? So yeah, but the questions, as far as the questions or test cases is concerned, it's ascending, right? It's not descending. So hopefully they will consider ascending. Let me, I have to just okay. So that means the code is okay. But see, here is a repetitive code, right? So you see this line is repeating in if as well as in else. So I can modify, I can basically optimize it by doing what? I can have this, because for both of the cases, it's just like taking a common out of a equation. Okay. Because it is coming in both if and else, you can just remove it, right? And replace the else condition here. So it's like, instead of this, do this. Now what happens? Whenever the x is less than E, would it work? Uh, is less than E. Yeah, yeah. So whenever this element is bigger, it will first insert x and then insert that element. Okay. Same output. Sorry, let's just replace it. Yeah. Now in that case, see, the L list is not modified because I have used a secondary list to copy every element. Okay. This type of questions you can expect. So here also they have did similar kind of, but yeah, similar kind of logic can you. A second question. Accept a sequence of words as input, create a dictionary. Now dictionaries also came into picture now. So until now you are only working with lists. Now dictionaries. Huh? Accept a sequence of words as input, create a dictionary named RealDict, whose keys are the letters of English alphabet. Okay, so A, B, C, D, these things. For each key or letter, the corresponding value should be list of words that begin with that key. Okay, for a given key, the word should be appended to the corresponding list in the in the order in which they appear in the sequence. Okay, you can assume that all words in sequence will be in lowercase. Okay, so it is like the insertion should be in the same order as it's coming from the sequence. So that is means we don't have to do anything, right? The sequence, whenever we are looping through the sequence, it gives us the order that, okay, whichever alphabet is, let's say O, right? So the first one, and then let's say anything that would uh, so the order in which they appear in the in the sequence will be same as in which the in which order they will appear in the keys list. Okay. So for example, see, all here it comes first and then R it comes second. So in the sequence they also come second. In the list they also come second, right? Okay, so that would be no problem because it will, so directly it will be something like that. If they mention that the order in which they appear in the list would be sorted by dictionary, then you have to sort the list. Sort the list based on the first character. First, like, so no, not first character, by the strings. So you can compare the strings, okay? It will compare it based on dictionary order. So you can also sort a list of strings. Anyway, so this is not a sorry, you do not have to print anything to the console. So we have to just write. So it's not a function. We have to just create the dictionary. That's it. Okay. So let's just copy one example. This one. SL string list. Oh, sorry, strings. Strings. Okay. A string, let's say, not string. And then how we can create the list? Split, right? We split at comma. So it will give me all the membering, let's say, which are comma separated basically. Okay. And then we can just loop through it. So words are this. Now create it. So now you can just create a dictionary, empty dictionary, right? And then loop through all the words. Okay. Okay. And now what you do, first see if the word zero, that means what? That is the first character, right? First character is in the dictionary. Then do what? Then you just try to like add it to the list, right? So we assume that, okay, let's just handle whenever it is not in the dictionary first. So by default it will not be in the dictionary because initially it's an empty dictionary, right? So if it is not in the dictionary, then what we should do? We should add that character and add a empty list and add that word. Three things. So insert the key, add a empty list for it, and insert the word in the list, right? So dictionary W0 is equal to a list with that word. Okay. Else, if it is already there, you just append it to the. So that means doing an append call on the dictionary on the list. Now after I have the key from what, like, the let's say R, right? I have A. I just get the list from here, from the key, and then just do append W. Okay. Now let's see dictionary. Yeah, this is how. So problems. So did they mention anything about you have to remove now? No. Okay. So you have to keep the recurrences also. So if a particular word occurs multiple times, you have to also keep those recurrences. Okay. Okay. Now next question. Now consider a grid world of n cross n. You are at the left bottom corner at cell 1 comma 1 to start with. A simple grid world for the case of n equal to 5 is given below for your reference. Okay. So your starting point is this. Okay. And you can move one step at a time in any of the four directions. Fine. At every cell, at every cell, the grid, at every cell of the grid, all four moves are possible. Fine. The only catch is if you make a move that will take you out of the border cell, you will stay put at the same cell. Fine. Constant. Okay. okay, so concretely, if you are at cell 1 comma 4 and try to move west, you will remain at the same cell. Or if you are at 3 comma 1, sorry, 3 comma 1 and you try to move south, you will remain there. So there are two restrictions, and I guess this should be 3 comma 2, okay, not 3 comma 1, because the picture shows this place. Okay, you will remain there. Okay, write a function named final that accepts a positive integer n and a sequence of moves as arguments and returns the final position where you end up in the n cross n grid world if you start at 1 comma 1. Okay, so you must return a tuple of size 2 where the first element is x coordinate and the second coordinate is y coordinate. It's very easy, right? So what you have to do whenever you are going outside of the grid, you have to just put it back there. So in any invalid move, let's say in this block, left and up, or basically west and north, those moves are invalid, right? So if you take them, you will be returned to the same position. That's a self loop. Okay. And there are two restrictions. You cannot move west from 1 comma 4. So here, right? You cannot move west, fine. And uh, I guess this is a wrong. So in the image, they have mentioned it like it's wrong. It should be 3 comma 2 itself. Sorry, 3 comma 1 itself, right? Because they have said only the corners are the border cells. Okay. Now 1 comma 4, it is okay, fine that you cannot take west. And if you are in 3 comma 1, you try to move south, you will remain there. So yeah, 3 comma 1 would be here, right? 3 comma 1, yeah, here. So you cannot take a south here. Okay. Now you have to give me this sequence and I will be telling, okay, where you end up. How I can do that. Okay, let me just show you one library I made earlier. See this library? So, this library I made in I guess in BTech. Okay. So here you can so I hope you know reinforcement learning, like at least heard about the term reinforcement learning, right? So you can teach a computer program to play a game. So in that case, the hardship was that it is hard to make your environments where you will, well, basically hard to find games that you can try solving. Okay. So what I did at that time, I created this library which can give you access, or which can basically allows you to build custom grid worlds where this mouse can move anywhere, but restrictions would be when there is a wall or there is a hole, right? That it will be dead at that position. So if it hits a wall, it cannot go beyond it, or if it hits a hole, then it will fall in the hole. Okay, so these are two obstacles, and you have to reach the cake. So the RL algorithm has to learn the policy that would lead that mouse to the cakes. For example, see, this is the policy like projected on the game. So what it learns, it at this step, it goes here, it goes here, it goes here, and then it goes down, then goes right, and here it goes up and goes to the cake. And see, wherever you start, right? Let's say I start from here. This also gives me a correct path of going to the cake, right? Let's say I start here, right? See, this also gives me a correct way of going to the cake. So this is exactly same but little bit simpler version of it. Anyway, so there are no intermediate blocking steps or anything. So let's just do it. Okay. So n. So what are the inputs? Only n, and then the sequence. So this is the n, and this is the sequence. Okay. So let's suppose n equal to 5 for the time being. Okay. And how I can how I can create a grid. Uh, Okay. So for let's just create what would be the most effective way of doing this. Let's just uh, okay, for I in range n for j in range n grid, and at the grid you have now rows, right? Rows is equal to, or row basically, not rows. Oh, sorry. This is one row you are filling, and then you are stacking the rows in the grid. Okay. So what will be the rows, and which is 1 comma 1? You see, 1 comma 1 is here, right? So it will go. This is the end. So it will be from bottom to top. Okay. So what I can do. So row dot append a tuple. I am appending a tuple of I plus 1 comma j plus 1. Why? Because it starts with 1 to 1. It counting starts with 1 here. Okay. So but Python counting starts with 0. So I have to make that transition that okay, I should be I plus 1 actually. And after one row is complete, I should not append it. I should insert it at what? Insertion should be if I want to push the whole grid down, right? I should only insert at the first position, 0, right? Then that 0, then whichever row is inserted at the beginning, that 1 1 1 1 2 1 3 row, that will be pushed down. Okay. And this is what? This is 1 4. Okay. In this direction, you have 1 4. Uh, let's just see. So I guess it will be j comma I plus 1 and grid dot insert the row at the 0 position. After I index and then the object, sorry, index 0, then the object. Fine. Then if I see the grid, yeah, it is what we expected, right? Now it is in the same grid as we are expecting it to be. Okay. Now where I have the starting position 1 1, right? And 1 1 should be what? Which location? 1 1 should be this location, right? So it will be uh, so start would be 0. Sorry, start location should be, let's just grid. I want to be at the last row, or basically n minus 1th row, 0th entry. N is what? Sorry, I have to do it. Yes. N minus 1th row, 0th entry here. Okay. Now the directions west, east, north, south. So we will have a dictionary for that. So the starting location is n minus 1 comma 0. Fine. Direction, direction. This is a dictionary. West, north, east, south. So west will be how much? So we'll be giving tuples or how much to move in which direction. Okay, so west is I have to move in the, so this is the, which is x direction. See, this is for selecting the row. So this is x direction. Okay, and this is y direction. And x is going here. So going west would give me minus y. So 0 comma minus 1. 0 comma, is it 0 comma minus 1? So this is increasing. This is increasing. So west is 0 comma minus 1. Fine. North is 1 comma 0. East is this way. So east is what? East is 0 comma 1, and south is minus 1 comma 0. So these are the directions for each of them. Okay. Now if I start with this position, okay, and I apply these things, then okay, for or I thought what I would say grid. Let's say I have the input. Let's copy the input also. This is the input string. Or move. This is the move, right? For MV in move. So for each move, first of all, what I will do, I will take the direction tuple. So what I have to minus actually. Okay. So D is equal to direction, and okay, these are all capitals. So W N E S. Fine. Now for each character, basically let's not keep it MV, let's keep it M. S move in move. I will get the direction first. So now I know what I have to minus. Okay. And there is, see, this grid 0 comma 1 will give me the final location, right? I don't have to worry about, because the start position is, I know, I don't have to worry about anything as long as I am staying within the boundaries. So the boundary should be what? Uh, uh, 0. This is the x boundary, right? 0 n minus 1. And then for um, uh, y direction, the boundary should be same, 0 comma n minus 1. N minus 1. It should not go beyond it. Okay, let's just see the grid once again so that we are doing it correctly. Now this is n comma 0. Okay, so if I go up, if the up movement is triggered, right, not, then what it should be? It should be 3 comma 1. So fine, 0 comma minus 1. Sorry, 3 comma 3 comma, sorry, not should be minus 1 comma 0. So if I am going up from 4 comma 0, it will be 3 comma 0, right? Now if I am going west, it will be what? Let's say I'm here. It is what? It is 3 comma 2. Now 3 comma 2, from here I can, if I take west, it would be what? 3 comma minus, like 3 comma 1, right? So it will be, it's same, fine. Now east is 3 comma 1, yes, fine. And south should be this plus 1. Okay, if I'm going down, it should plus the this indexes, right? Fine. Now what I will do, for M move in move, direction I get, so I have this directional what I have to minus, and I have the start position here. So start is equal to, I have to minus both things, and clip the values. So clipping the values will assure that whenever it reaches a dead end, it will revert back to the same position, clipping the values. Okay, and let's write a clip function. uh, Clip function should look like this. Clip, let's say value minimum I know, maximum, sorry, min I know, max I know. I have to keep the value within that range. Okay, so if my value is less than minimum, return minimum. If value is greater than maximum, return maximum, else return the value. This is the clip function. Okay, so basically it clips the boundaries. Whenever it is going beyond the grid world, it will try to clip it. So that simulates the object being returned to the same state. Okay. Now start I know. Now let's define another function, apply move. Okay. What it takes the start and the move, and what it does, it so start x comma start y is equal to start. This is how you unpack tuples. Move or mx comma my is equal to move, and now you return what? Return tuple of clip of start x minus mx comma same clip for y as well. Click for y. And now to not pass this min max values like two times, what I can do, I can, like, let's say define them here, or basically have default values for them as n. If I don't pass them, it will take n as the default value, which would be the maximum minimum value, right? Or actually, sorry, n minus 1, because in Python it starts with uh starts with n, like 0 to n minus 1, right? So sorry, minimum value should be 0. Okay. So now start, I will do what? I will do just apply move start comma move m. Okay. And after I have passed through all the moves, right? Then what I have to do is I have the start with me. So it's basically replacing it, right? So it's basically overriding it over time, applying the moves as the, let's say, the string is getting parsed. So at the end, I have that x, so like start x have the final location, start y has the final y location. So grid start 0, start 1 would give me the final position of the grid. Yes. So what it does, move, apply move. Okay. It says that this move direction M, right? Oh, sorry. This should be D, not M. M is the move for the string, right? Now if I run, it is at the 1 comma 1. So let's just print where it move, print start, or yeah, and print start at the beginning of the, see, this is how it moved. 4 comma 0, it reached back to 1 comma 1. Why? Okay, what we can do, let's see, that there should be a bug here. I should print the grid, okay, and put put this wherever the thing is, I should put star there. star to represent that. Okay. Okay. And print the grid and sleep for some time. One. Let's say one. Was 0.3. Mm, it is printing like this. It should print it like this. Uh, 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 uh. Write a print function. Let's see. Print grid for each row in grid for each value in grid print row print value and with space and after it ended just do a print. This is my print. Oh, I replaced the print itself. Okay, now the grid looks like, so it only roam around here and the final position where it ended start 1 0 comma 4. So it is grid start 0 start 1. Oh, anyway, it ended at 1 1. So what is the move? Let's see the move first. Okay, north, 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 east, east, east. Okay, north, north, east, east. Let's see if it works on. Okay, so see, we spotted the problem. So whenever I'm going north, it's going, it's actually keeping it in the same location, right? So somehow it is what is happening whenever it is getting north. Oh, sorry, my bad. We have to plus it because our moves are signed. We have our moves are signed already signed, right? So you have to just plus it. Yeah. So north, east, east, 3 3. Here we are at this place. Then it is fine. Now just remove all this thing. Uh, Remove the print grid as well. And after we
Um,
yeah
Hello.
yeah
Yeah, I think like we can skip the programming part, maybe otherwise we won't finish the week's contents.
oh sorry. I was just like these type of questions may come. Okay, so like
Uh,
for this
actually,
question,
uh, actually we won't be getting any programming questions. It's only objective type exam.
but you are supposed to also program in the test, right?
No, no, no. We got a mail that it's only
Mm-hmm.
objective. This time there's no programming exam.
Okay. Thanks for letting me know that. Let's go to week 6. Anyway, let's see. So we'll not do the programming questions then. The this MCQs. Okay. So what is the output of the following code? So my str. Okay. If n is less than 2, return n. Else return mystery n minus 1 n plus 2. This is Fibonacci, I guess. So yeah, this is Fibonacci. So 25. And how we are supposed to like run this code in my mind and like answer this.
Yeah, this is the trick. So this we have to learn how to how to simulate this code in our mind that we have to do in the exam.
But you can always do that by like if you have a calculator, right? You can just if n is relatively less, then it will create a big tree actually. No, it will be if the branching factor is 2 and it is 5, right? So it will create a tree of log 25. So log 25 is what? NP dot log 25. So it will create a tree of depth 4, okay, of branching factor 2. So you have to, I guess, write that tree by hand, and there would be how many nodes? N into n minus or something. There will be a lot of nodes, and then you have to take a sum. Uh, uh, okay, I don't think I can find like I can think of any easier way of solving this. Okay, I would what I would do if I have this type of questions in my exam, I will just write like in the graph sheet, I will just create the tree, sum each element, and have that answer. Okay, because like anyway, remembering how to do or how to sum this, it's not good. Okay, so which method in Python is used to convert lowercase letter to uppercase? To upper, right? Sorry, to not to upper. It's upper capitalize case fold or swap case. So what it does, convert lowercase letter to uppercase. It is upper. Anyway, min max. The min max strategy often referred to as min max algorithm in decision making algorithm used in game theory and artificial intelligence. Okay, in common, it's commonly employed in two-player games to alternate turns and perfect information such as chess or tic-tac-toe. What is the primary objective of a min-max algorithm? So in a min-max game, Uh, hmm, hmm. Let's see what min max is exactly. Forward the yeah. Okay, so hmm, hmm, wait. Hello? Yeah, somebody saying something. So let's see min max algorithm first. I forgot what is min max algorithm. So consider a game that has four
Min-max
final states.
algorithm, min-max algorithm is for normalization.
No, that min max algorithm is for another thing, right? That is for data science perspective. But here, this min max algorithm is something else. It is actually used in classical AI to let's say which move you should choose to win a game. That's it. Okay. So min-max is kind of a backtracking algorithm. It is used in decision making and game theory to find optimal move for a player, assuming that your opponent is always playing optimally. Okay. So okay. So you will take left turn or right turn, something like this. So you'll create the whole tree of moves, and then whichever path has the highest score, you follow that. Okay, and let's say so there can be some paths, right, that initially gives higher rewards, or let's say when you score more, but later down the tree, your opponent gets more points, right? So what is our objective? Let's say to optimize our score, right? So this is how it is done. Wait, I don't have the, or let's just use the tic-tac-toe example. Yeah, this one. See, in this case, if I start with this position, right, and I take all these three moves, so there can be, so see, I can place the cursor here, I can place the cursor here, I can place the cross here. There are three positions that I can place, and this is not the whole tree. So the whole tree should be lot bigger, right? So like it will start with only all the entries being null, and then it will grow till all the entries are filled. So it's a sub part of the tree. Okay. And now what are the three decisions that I have that this cross can take? Cross can only have these three positions. For that three choices, there are the zero can basically, or this zero can take two choices, right? And here it also can take two choices. So what it does, in which path the let's say cross is my player, okay, and zero is the opponent's player. What it does, it tries to find a path that maximize its reward. Okay, so why we have to look through the whole path? Because it can happen that initially by taking some moves I am winning, but it leads to some situation down the tree that the opponent is getting more points now. Okay, for example, let's say if I place two consecutive crosses here, and meanwhile the opponent cross two here. Now if in the third move, if I place a cross at the top, my opponent would win, right? So that cross, so these two will kind of make the game in favor of me, but that taking these two decisions will lead the opponent to win, right? This type of thing. So what it does, it basically follows a path where the the main user, or let's say where my user wins in that path. So now answering the question would be easier. That is the question. The min-max strategy often relates to min-max algorithm, decision making used game theory. Okay, it's commonly employed in two-player games. The alternative transit part. Okay, so the alternate player or the competitor, they take the greedy decision. So they take whatever is the greedy choice for them. Okay, but we don't take greedy decision because it can lead to failures. So, such as chess tic-tac-toe, what is the primary objective of min-max algorithm? Maximizing the player score, minimizing the opponent score, maximizing the player possible losses, maximizing the number of moves. So it would maximize the this maximum possible losses. Okay, or maximize the player score basically. So what it does, it gets all the paths, or it suggests all the paths where by following those paths you will win. Okay, he tries to take the path such a way that it minimize the possible losses for the like player zero or the main player. Okay, so Winmax algorithm, I guess you can find a good tutorial in YouTube. Winmax algorithm. Yeah, you can just, if you just put, I guess this one would be good. So just try and see this tutorial once. You'll see what it actually does. Then it finds all the paths in which the player zero or the main player would win. Okay. Okay. Typecasting refers to conversion of data types from one to another. Python provides several built-in functions such as int, string, okay, find, all, among others, to convert between different data types. What would be the output of the following code? Okay. Okay. This is an like value error. Okay. Why? Because it has a numeric, so alphanumeric values. These are alphanumeric values, right? So it should be only numeric values. Then you can only cast it to integer. Fine. What terms is used in programming languages when a function call itself? Recursion. Right. Consider the following snippet of code. Fine. Equal to 0, L modulo 2 and function 1, else L0 modulo 2 is equal to 0. So if the first element is odd, sorry, if the first element is even, then return 1 plus function L1 colon. Okay, so 1 plus the rest of the list. Okay, and else return the function. Okay, okay. So it will return. Yeah, so it will count the number of even numbers. Okay, so whenever we have the even number, it will add 1 1 1, and at the end it will be empty, so it will return 0. So 1 plus 1 plus 1 plus 0. Right? And if it is an odd number, then nothing, no one is added. Right? So that's it. So it will count the number of odd numbers, sorry, even numbers in the list. Yeah, okay, it totals the number of even elements in the list. Fine. Consider the following code snippet. If okay, if L minus 1 modulo 2 is equal to 0, L minus 1 plus fine L. Okay, so it's same. So it reverses from the, like, it traverses the whole list from the reverse direction, and uh, what it does, it tries to count the number of odd elements from the last of the list. That's it. And basically sum them all up. So it sums the odd numbers. Yeah, not even, because it is one. It returns the sum of all odd numbers. Fine.
In this one, why it's odd? It should be again even now because modulo 2 is
One.
okay. It's 1.
It's one.
Okay, not 0. Yeah.
Okay. Uh, what purpose does a base case serve as a recursion? So base case is a termination condition, right? So it prevents the infinite recursion and ensure termination. Base case is this one, okay? This one. Whenever it like breaks out of the recursion and doesn't return itself. Okay. Consider the following function f that accepts an integer as argument n. Fine. If something and then n greater than 1, if n to the power, so root is equal to integer of, so if it is a so what does this mean? So if it is an like if it has a whole number as a root, okay, so for example 25 would be satisfying this condition. So that root and also the integer of the root would be same. So it's okay, return 1 plus this uh, else. Okay, so if it has a whole number as a root, then 1 plus that let's say mm, that root value, okay, then you are taking the root of the root again. And if n modulo 2 is not equal to 0, so if it is an odd number, then 3 times n plus 1, okay, else return 1 into n divided by 2. So I guess for this number you have to like write the whole tree down. So not tree, actually it will create a like skew tree. We'll see. I just copy this one. Wait. So now wait here. Wait here. Okay, if this is my question and I have to take what 10,000, fine, 10,000. So at the first call, what will be the return? 10,000 has a like integers
100.
root, right? So it will be 1. So see, this would happen and it will return 1 plus f of 10, sorry, 100, right? And then 100 also have a complete 10 times 10. So 1 plus f of 10. And then 10 doesn't have that root, and 10 is not an odd number. So else would work. So 1 plus 1 plus f of, so now 1 plus f of 5. Now 5 also is not, 5 is an odd number. So this would work, right? So 1 plus 1 plus 1 plus 1 plus f of 3 times 5, 15, 16. So f of 16. Then 1 plus 1 plus 1 plus 1 plus, it is a whole number, so 4 of 4, sorry, 1 plus f of 4. Now this is an
It will be f of 18 or 16.
16, right? Here 3 times 5, 15 plus 1, 16.
Okay. Yeah.
Okay, so now 1 plus 1 plus 1 plus 1 plus 1 plus f of 4. 4 is what? 4 is a whole integer which have like it has a whole integer as a square root, right? So f of, so 1 plus 2, 1 plus f of 2, and 2 is what it's not this, else would work. So 1 1 plus 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 f of 1. Okay, and if it is greater than 1, less than 1, and so if it is 1, then it will return to this else, so it will be 0. It will be 1 2 3 4 5 6 7. So answer would be 7. Okay, The answer is 7. Okay. What is the value returned by f of minus 8? So f of minus 8, let's just do the same thing again. F of minus 8, it is less than 1. So this would happen. So 1 plus f of 8 at 64. Now 1 plus f of 8. Again 1 plus it reaches to the L's, right? So 8 times 3, 24 plus 1, 5. F of 5. Sorry, 1 plus f of 5. And now f of 5 I know, right? F of 5 is what? From here. So it will be replaced with this. So 1, 2, 3, 4, 5, 6, 7.
So
So
this
1,
will be
2, 3,
f of
4, 5, 6,
5.
7.
This will be f of 5 or f of 4.
Sorry. Let me see. 16. So this would be actually f of 25. I jumped a step and then I missed it. Okay. Anyway, f of 25 will come here, right? Now it becomes 1 plus f of 5. And here I can replace it with the earlier computation. Here from here, this part is f of 5, right? Now 1, 2, 3, 4, 5, 6, 7, 8. So the output should be 8. Now it's 5. Now it is 5. Okay. Me.
This 25 should be 4. It's because it's even, so 8 by 2 will be 4.
Oh, okay. Yeah. 8 by 2 would be 4. Okay. And in this we know 2 plus 2. Okay. So 1 plus 4 is this. So 1, 2, 3, 4. Again 1 plus 4. 4 should be okay. These two only. Ah, copy. Paste. So 1, 2, 3, 4, 5. Okay. Fine. So it will be 5. Okay. So now we'll not do the programming questions. Week 7. So week 7, yeah, we have suppose. As per our record, we anyway the some game also known as this involves a player moving their pieces around a cross-shaped board based on the throw of the dice. The objective is to reach the center of the board. Mm, the steps required to implement the game are below, and then you have to number them. So the game is what? These are, I guess, common questions. See, previously also in the last week also see this kind of thing, right? So you are taking some input and outputting, let's say something, and the steps are there. You have to write the steps and give that number 1, 2 in the sequence. So roll the dice or simulate throw to determine the number of steps player can take. Move player's piece based on the dice roll. Check if the new position is within the board limits. If it is, proceed. Otherwise, stay in the current position. Fine. Create a cross-shaped board. 4 rounds. Okay, fine. Check if the player has reached. So 2, 3, 2, 2, 1, 3, 2, 1, 3. So this is easy, but when it becomes hard, when let's say these also are kind of break into more steps, right? So here it has only 3 steps, so it is easier to like understand which order we should put them. But in the last week we have seen that it can be like 5 6 steps as well, and then it becomes little bit tricky. Given below is the simple algorithm for a snake and ladder game. Now it becomes a bit okay. Create a board with positions numbered from 1 to 100. Find the position of the snake and the ladder in the board. Each snake and ladder connects two positions. Each snake or ladder connects two positions. Fine. Roll the dice to get a random number from 1 to 6. Move the player pieces forward by the number obtained by the dice roll. Check if the new positions contain head of snake or the bottom of a ladder. If it does, move the player to the corresponding position as per the snake or the ladder. Check if the player has reached or exceeded position 100. If the player has reached or exceeded 100, declares the winner. If not, proceed to the next player's turn. Repeat the process for each player turn until the player wins. Okay. The following variations were suggested for the algorithm. If you are using a octahedral dice, okay, I mean that means you have 8 heads instead of 6, instead of dice instead of normal dice. Step 2 has to be changed to generate a random number from 1 to 6. Yes, 1 to 8. Yes, because you are using an octahedral dice, right? So now you have to generate number from 1 to 8, not 1 to 6. So yeah, step 2 has to be changed. Modification is required only in step 1 if you are using a board consisting of 200 in tiles instead of 100. So yeah, here we are just rolling the dice, and here we are just like changing okay, here we are just checking whether it is reaching the position 100, right? So we have to change both of these. This one where we create the board, as well as when you are checking for the winner, right? So we have to use this only. It says it only modifies step 1. Now modification regarding both 1 and 2 if you are using 200 tiles in 1. Yeah, so it will be 1 and A and C. So this option A and C. And Nissan enjoys Nissan enjoys the game of snake and ladders, but feels that the player should be given extra choice if the player lands on a prime number tile. Assume that no prime number tile has a snake or a ladder in it. So that means what? So whenever you reaches a prime number tile, you are rolling the dice again. That's it. So you'll get two chances. He generates the following function is prime to check if the position of the player is not prime or not. However, there is a chance that there could be a small error in the code. Identify the line number corresponding to the error. In the absence, write a -1. So we will check whether it's working prime number code or not. So position, if position is less than 2, return false, because 0, 1 and 2, these are not counted as prime numbers or anything. Now if I in range okay, if 2 comma position root over a position plus 1, if position modulo I is equal to 0, okay, return true. This should return false, else true. Okay, it should be
In line
-1.
number, no, in line number two, it should be only
Okay,
less than, not equal to.
why not equal to 2 is not a prime number, right?
It's a prime number.
Two is a prime number.
Okay, okay, okay. So okay, anyway, so 2 is a prime number. So okay, so but okay, so then I numeric 2 is a prime number. Find the error in the line of code written using the library turtle to draw a square in the absence of error. Okay, so it will create a square. So turtle you when the C starts forward and right. Okay, forward 100, right 30. So it will be 4, I guess. This should be 4 because it has to create 4 edges, right? It will be 4. That's it. Now like the spiral pattern, like the spiral pattern, The matrix can be printed in many patterns on form. Okay. In the snake pattern, the element of the row are first printed from left to right, and then the elements from the next row are printed from the right to left order. Okay. So, mm, so this is how they are printed, and then after that you print them like this, and then like this. Okay. As a crucial step in the algorithm to print the snake pattern is to check the row parity remainder. Okay, remainder when the row number is divided by 2. Identify the correct statements regarding the step. Assume the normal indexing in a matrix starts from 0. Fine. When parity is 0, you print the elements of row from left to right. When the parity is 1, the okay. So I didn't understand this question actually. So do you know what they, or did you get what they asked? Like the spiral pattern, okay, can be printed in, okay, fine. The separate elements from row are printed first, left to right, and then elements from the next row are printed from right to left. That's fine. A crucial step in the algorithm to print the snake pattern is to check the row parity. Remainder when the row number is divided by 2. Okay, okay, okay. So whenever you are let's say the row number is 2, that means the third row. Okay. I think the row indexing starts. Okay, third row. Then if it will be either odd number index or even number index, then okay. So whenever it is an odd number index, you print from right to left, otherwise from left to right, right? For 0, you print from left to right. Then for 1, the remainder would be 1. You print from left to right. Then from 3, 0, 1, 2, it will be 0 from left to right. And then for 3, it will be 1, right to left, something like this. So when parity is 0, you print element from left to right. When parity is 1, you print elements from, no, it is not correct. When the parity is 1, you print element from right to left. So these two. Okay, so the parity is when you divide the uh, row index, 0th row, 1th row, these things by 2 and get whichever value, 0 or 1. Okay. Which of these conditions guarantee that the element is a boundary element of matrix of order m by n? It takes I as the row index and j as the column index, okay, of the element to be checked. All of these are correct. So the boundary elements are what? The min max values. We are clipping it before, right? So it for rows it will start from, so it's a m by n matrix. So there will be how many rows? M by n. So there will be n rows and m columns, right? So take I as the row. So row will be what? 0 to m elements will be there. So it will start from 0 to m minus 1. Columns opposite, 0 to n minus 1. Okay. So given a set of 4 integers as input, the following code tries to print elements in in form of sequence. It's given a set of 4 integers as input. The following code tries to print elements in form of sequence matrix of order 2. Okay, but the code might contain errors. To identify the line number corresponding to of the error, give -1. From a square matrix of order 2. Okay, so basically it fills the 2 by 2 matrix. That's it. Okay, so what it does, there is a numbers list, append input, int input, fine. So it's filling up the rows. One row is filled, matrix 0 0, fine, fine. So it's basically taking four numbers in a list. Matrix 0 is equal to numbers 2 colon. 2 colons mean what? 0 to 2, 0 1, 2 indices, right? And matrix 1 would be 2 colon. So this is wrong. This should be 3 colon, right? because this is excluding and this is including. This could be 3 colon nothing. So yeah. Oh, sorry, 0, 2. So yeah, it's correct. See, the numbers you are taking first is 0 and 1, and then 2 and 3. 0 and 1, 2 and 3. Okay. So this 2 is excluding and this 2 is including. Okay. How you can write a data to a CSV file using CSV module. CSV, like, these things you have to remember. I have not used, like, like, I have not used this CSV module in any of my code. The CSV or writer. Any I like the best thing you can do wherever you are writing CSV file is to convert it to a pandas data frame and write it. But anyway, yes, these things you have to remember. Okay, CSV dot writer. Which object is commonly used for reading rows from CSV file in Python? CSV reader. Okay. I haven't used this library, CSV library. Okay, gmplot is a Python library that allows you to plot data on Google Maps. Fine. Uh, uh, the syntax for creating a base map with gmplot is matplotter. This the parameters are geographical coordinates, that is latitude and longitude, and zoom resolution. I guess both of them are correct. The gmplot I have used in one of my work. Yeah. Anyway, so both of them are correct. So the call is like this, and it creates Google Maps like windows. Okay, you can basically zoom on a section of the map. But anyway, I don't like this. So how we are supposed to remember this? Suppose for, let's say, gmplot, if you remember it's fine, but for any library you cannot remember these calls, exactly these calls. Okay. uh, so I guess they will set the questions accordingly, and there will not be many questions like this. Okay, where they are asked for exact like parameter list of a call. Okay. Week 8. Okay. Which of the following statement about tuples in Python are correct? Tuples are mutable, tuples are immutable, meaning their elements cannot be changed. Tuples share a close resemblance to list. Yeah, but they can be indexed or sliced just like list. Okay, the main point of difference between list and tuple is that the tuples cannot be updated in the place. Okay, elements in tuple.
Can you zoom the screen like it's very small? Yeah,
Okay,
thank you.
okay. Elements in a tuple cannot be deleted. Fine. Which of the following statements are true about the tuples? Fine. A tuple can hold mutable objects. Yeah, they can hold mutable objects, I guess. Okay, a tuples can be nested. Fine. A tuple can be converted to into a tuple and vice versa. A list can be converted to tuple. Fine. A tuple can hold non-homogeneous sequences. Yes, all of them are correct. So the main
The
thing is
first
you cannot.
the
Yeah,
first one,
this
tuple.
mutable object, right?
Yeah.
Yeah, so tuples cannot be changed, like their entries cannot be changed, right? But let's say there is a ball object or there is a person object in a tuple, you can change the in like you can mutate the person object itself, but cannot mutate the entry in the tuple. Okay, so let's say I want to.
Okay.
Okay, so let's just verify it also. Let's say I have a small. Let's do like this. L is equal to a tuple of 1, 2, 3. Okay. Now I cannot modify for a single tuple. I have to do like this. So this is a tuple of list. I can always append another entry the list. Okay, it is valid. See, the fourth entry is added, but I cannot change the zeroth to be some another list. It is not possible. I can modify the entry, but I cannot change the binding. Okay. Which of
Here,
the following?
here the index in L index 0,
Mhm.
it's a complete list now 1, 2, 3.
Yeah, it's a 1, 2, 3 list that can be mutated, right? So currently, see, I muted the list, right? But I cannot reassign the list to some other list. So
Okay.
let's just have another list also, right? Then it will be clear. So this is the tuple before L. L is the tuple of two lists. Okay. Now if I append the element 4 in the first list, it will be reflected so that we can mutate the entries, but we cannot, let's say if I want to completely replace the list to some other list, let's say ABC, list of ABC, right? List of A, B, and C, it will show me that okay, it cannot, the assignments are not supported. So basically until the reference is same, we can mutate it. Okay, so this
Okay.
list has the same reference in the tuple, right? But we can mutate the list itself, but cannot mutate the reference which is in the tuple.
Okay, understood. Thank you.
Now, which of the following best describes the role of matplotlib in Python? Okay, matplotlib you already know, right? We had a segregated uh, week for that. So it was a plotting. It is used for plotting. That's it. Used to create figures plot, adding labels, and other visual representations. The following paragraph is an excerpt from a talk given by okay in reality okay. The text processing plays an important role in analyzing text data given a piece of text. Which of the following piece of code determines if how many words are there in a text? Which of the following piece of code determines okay. Now there are okay. So this is the whole code. While null in sentence dot remove null. So this removes all the empty spaces. Word sentence in sentence, word split at space, extend words, length of words. Fine. Proc words for word in words. If word is equal to null or word is equal to, so that means what it the sentences. So it basically parses word character by character. Okay. If not that, so it basically skips all the like these spaces, empty characters, and these dashes. Okay. And this one is what is the question again? Which of the piece of code determines if how many words are there in the text? So here we have all the things that are splitted at space. Okay, so there can be like let's say a dash which has left space and right space. So it will be treated as a as a word. Okay, but what it does, it only append those words. Okay, which have like which has any meaning. So it removes all the dashes. So if it doesn't have dash or this empty space, then only it appends the word. So it's a valid word. Okay, so this is so you have the words computed from this block of code, right? And then after you run this block, it will extract out all the valid words. So the answer should be this one. Yeah. Question 6 and 8. Define anagram. Anagram is, I guess, uh, wait, anagram. There is a question. Word 1, word 2. If length of 1 is equal to length of word 2, not equal to, then return false. Their length should be same. If n in word 1, if word 1 dot count n is not equal to word 2 dot count n, count I, okay. So each character should has the same count also. So whatever characters are there, they should have the same count as well as their length should be same. So basically they are a jumbled version of each other. Table and some jumbled version of table. Those are anagram. Okay. So how does the given code check if two strings are anagrams? It compares the length of two strings if they're equal, okay, and it usingly counts the occurrences of character present at even places in both strings. This is not correct. It counts all the characters. It iterates through each character word one and compares the count in character. So this is correct. Compare the length of two strings. If they are not equal, it processes to check character counts in each string. This one is also correct, I guess. Process the length of two string if they are not equal. Oh no, they should be equal. Right? So this is false. These two. This first one and third one. Okay. If two strings are anagram, what would be the output of the above code? If two strings are anagram, what would be the output of the above code? The output in case of anagram, listen and silent. See, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. LISTN. Yes, is true. Fine. A Boolean value. Fine. Because it will only return true or false. The output of the anagram, hello and world. So these are not anagrams. It will be false. The output of the case anagram KRN race CARE. Yes, this is true. So 1, 2, and 4. This will be correct. 1, 2, and 4. Consider the tuple colors red, green, blue. What is the result of colors plus purple? See, it will create a. So this is not a valid tuple. Okay. So for a single element tuple, there should be a comma at the end. There should be a comma, purple comma, and then this first bracket would create a single element tuple. Okay. So because it's not a single element tuple, it will consider it as a string object. Okay. And these are basically general arithmetic uh, brackets. So they will be omitted when the computation will happen. So we cannot add a string directly to a tuple list of or a tuple, right? So it will create a type error. You cannot add a string to a tuple. Which of the statement accurately describe the use of okay. These are data frames in sentiment analysis. Okay. So is this. Okay, so it is a sentiment analyzer library which already have the analyzers inbuilt, so you can just take inferences from them. Okay, so I guess you remember that to have the sentiment predictions, we have to train a model from scratch, right? We have to train a neural network model from scratch. Here, for this Veda library, what it does, it gives us objects that already have pre-trained this sentiment analyzers. Okay, so Veda is a machine learning based tool which is used to data frame to analyze sentiment images.
What is a lexicon?
Lexicon. So these are, I guess, uh, so lex is basically like the primal form of a word. So let's say running, right? That run. So it basically analyze uh, the base verbs actually. That's the lexical analyzer. Okay. Or basically it creates tokens from the sentence and then analyze the tokens from their uh, like base verb versions. Okay. So but Vader is not. I guess it is not a machine learning based library. Okay. Intensity analyzer. sentiment intensity analyzer, and okay. Hmm, okay, violence aware detect dictionary and estimate reason. Okay, so it is a rule-based library. Okay, so what it does, it creates the base verbs and tries to match it with a dictionary that it has. That okay, if dislike, let's say you in the sentence there is disliked or dislike, or let's say any like past verb, this, or let's say hated, right? Hated, this type of verbs. So what it does, uh, it generates the base verb hate, and then it tries to reason that okay, because hate is present in the sentence, it tags it as a negative sentiment. Okay, so it's a this one. It's a lexicon and rule based sentiment analyzing tool. So lexicon means what? It basically process tokens instead of sentences and treat each token from its base verb perspective. So if there are, let's say, ing or ed appended to a verb, it will try to get the base verb and then analyze, or let's say basically match it with its own dictionary. That whether, let's say, a list of verbs, if they present in the word, they will be classified as a negative sentiment. Okay. So it doesn't use machine learning as we have like we have tried the machine learning approach, but Veda doesn't use machine learning anyway. Statement one: the method used for clipping the image in PIL library is transpose parameter. Statement two: transpose is not to clip the image. Okay. Um, oh, sorry, flipping, not clipping, flipping. Yes. And CLA है contrast limit adaptive histogram equalization is favored over AC adaptive histogram equalization for its advantages in handling noise. Okay, so I guess these are like facts, something like this. You have to remember this. So contrast limit adaptive histogram equalizations and adaptive histogram equalization. This is a superior version of this. Okay, it limits the contrast. So basically, so there will be the highs and lows of an image will be limited. Okay, even if you change the histogram, color histogram, it will not let it changed so that the image loses the content. Okay, here they are saying the both the statements are correct. So transpose is to flip an image. So you can transpose the x and y direction of the image. So the rows and the columns you can transpose them. Okay, in NumPy also the transpose function is there to transpose a matrix in, let's say, row to column, column to row, these kind of things. Okay, so we can use that for flipping the image. Let's see if I transpose the image and make the row column and make the column as row, then it will basically transpose the image in left to right. Okay, and top to bottom also. Left to right, top to bottom. Those two transpositions will be there. Consider the following snippet of code: word ABCD, word list ABCD, and word tuple this. Which of the following snippets of code will throw an error? Yeah, we cannot replace this. So first is word list 0. Word list 0 equal to Z. It will be working fine. Word string 0 is equal to Z. No, strings are immutable. Strings are immutable. So this would create an error. Also, this would create an error. So string and tuples, both of them are immutable. Okay, you have to reassign them whenever you are changing any index. So these two will create an error. These two. Okay, week 9. As well, what is stylometry?
Can zoom the screen?
Yeah. So See, what is stylometry? The study of language evaluation, the study of linguistic style in written text, the study of speech pattern in public speaking, the study of language acquisition in children. Okay. So the study of linguistic style in written text. Okay. So that means how so it's like how Shakespeare has written a text or how it's any other author has written the same text. That that pattern is actually considered under stylometry. Okay, the writing style. Okay. What is the different attributes that can be checked in addition to average word length to identify the style of a particular author? So it is like, let's say I want to identify which author has written a document. What I can do, I can have an histogram of all the words that that person is using. So sometimes you might have seen that so some particular person can use and multiple times in a paragraph, right? So their paragraphs are very and heavy. So if I do a histogram and see how many number of ends are there, I can tell, okay, if that person has written the document. So this is what they're saying. What are the different attributes that can be checked in addition to average word length to identify the style of particular. Okay, average in addition to average word length, right? So that means how heavy a particular, let's say, which words a particular person choose. Okay, they can use simple one or they can use like jargons, right? These things they we can also identify particular author by that like usage of jargons. Okay. Punctuation usage, I guess this punctuation usage are almost same, right? Because these are grammatical things. But they are saying the punctuation usage is also correct anyway. But so now it will be hard, right? Sometimes let's say a particular author can miss punctuations, but nowadays we use Grammarly and all those stuff, so punctuation would be more or less similar. Okay. Or actually, no, not similar. Punctuation. So let's say I have a tendency of joining sentences, right? Let's say joining two simple sentences and making it as a complex sentence. So I will miss a full stop there, right? Instead, I will have a comma, right? Or somebody who is writing the paragraph in sentences, simple sentences, they will have less commas and more full stops. Yeah, so this would also be correct. Word frequency, fine. So which word, let's say and, I am repeating and multiple times, that thing. Usage of stylic device like metaphors, similar uh, etc. Okay. Average sentence length. Sentence length, obviously, let's say if I am merging two simple sentences, it will increase my sentence length. Usage of stylistic devices like metaphors. Okay, yeah. So this is like how the person usually write its paragraphs. Whether they use metaphors, give examples, something like this. Okay, let's say someone is prone to giving multiple examples in their paragraphs, then we can identify them. Okay, the following code tries to perform natural language analysis for a small piece of text without using NLTK library. Fine. NL Python natural language it words in word, length of word, sum x, y by x. So y by length of x. Okay. So what it does, it takes the sum of all word lengths and then divided by the number of total words. So that gives us what? Average word length. Okay. Print y comma z. It gives us average word length. That's it. Select y represents the sum of length of words in text. Fine. Z represents the average word length. Yes. X represents the list where each index of the list correspond to the length of the corresponding. Yes. The output of the code will be 36. Okay, now we have to, okay, this is what 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 8 7 8 1 2 3 4 5 6 7 8 9 10. 6, 7, 8, 10. And so you can do it. Let's say just sum the number of lengths. So these lengths you have to sum, divide by 1, 2, 3, 4, 5. Whatever you get from there, it will be the output. Okay, and the sum would be here. So I guess all of them are correct. The following code tries to calculate average sentence length of a given block of text in form of a file, assuming that the sentences always end with full stops and that there are no ellipses in the block of text. So these are the ellipses. Okay, so if there are consecutive 3 full stops in the block of the text, but the code might contains errors. Identify the line number corresponding to the error in absence of a write a -1. Okay, so we go try to calculate average sentence length. Average sentence length. Okay, so it tries to compute average sentence length, and the sentences are splitted by full stop, and it reads from a file. So, okay, so first of all, it takes a file name as input from the user. Open that file as a read mode. For sentence in text dot split, okay, it will read the whole text dot split at full stop. So it will create the sentences. If sentence dot strip would return, it will always return until and unless it has no value, so or empty string, which will not be the case because there are no ellipses. So this would always return true, right? So this is a dead code. And sentence dot strip dot split at spaces length. Okay, number of words. Average length is equal to number of words divided by length of text. Text is what? Text dot read. No, right? Length of it should be what? It should be average average sentence length of each block of text from a file. So it should be number of sentences, right? Yeah, so this line is wrong. This line is wrong. So number of word counts are fine. Number of words, length of number of words for each sentence. So it should be actually length of number of words. Sum of number of words divided by length of number of words. This 5 is wrong. 5 is wrong. What does the following code do? This network X library, random ngx, okay, node in 1 to 6, g dot add. So it will add 6 nodes. Length g dot edges length, okay, length of g dot edges is not equal to 10. So until you have 10 edges, what you do, you randomly sample 2 nodes. Okay, so random dot sample 2, it will, so from this list it will take 2 index to take 2 values, randomly choosing 2 values. So 1 to 6. Okay, basically 1 to 5. So 1, 2, 3, 4, 5, and then add a node there, then print nodes and edges. So what it does, it creates an empty graph, adds 6 nodes until it has total 10 edges. It tries to add nodes to them. Okay, that's it. So a graph having 5, so a graph having 5 nodes which are integers from 1 to 5 and 10 edges in total is created, and the edges and nodes of the graph are printed. Yes. Okay. You are analyzing a social network where individuals are represented as nodes and friendships are represented as edges. Fine. What do you, what would be the most important graph property to study to identify influencer? So see, this degree centrality is there. Okay, so whenever, let's say, what is influential people, so that means lot of people look up to them, right? So lot of people have connections with them. That means the graph, wherever there is a influential people, there lot of connections will be there with that particular node. That is called a degree central node. Okay, so number of or how many connections a particular uh, node has would represents a if influential person in the network. So the node degree, that would be the answer. Okay. In the small world experiment conducted by Stanley Morgan, okay, or Stanley Milgram, okay, participants were asked to send a letter to a target person through acquaintances. Okay, what was the average number of intermediaries required for the? So this is called target person through. What are the average number of intermediaries required for the letter to reach the target? So this is some experiment which is conducted by this guy, okay, and they computed the minimum or the average hops took to reach to the target person, okay, and they basically, so someone can upload their uh, job to another, so they have to send a letter to someone so they can upload to another person who can upload to another. So they run the experiment and found there are at least 3 acquaintances that were required, okay. So acquaintance 6, sorry, 6. So these are something you should, like, you have to remember. There are not, like, nothing you can do about them. Okay, just facts. Given a file with edges of the graph,
In question number 4, uh, there is
this one,
yeah, there is uh, not 4, maybe 3 in question 3.
question 3, yes.
Yeah. So there was another question in which there was strip also and split also. So split
Okay,
is
okay.
splitting wherever there is a space.
This one, right?
Yeah,
Okay.
yeah. So split is splitting wherever there is a space, or
And strip
is
is,
it
no, yeah. So if you don't pass any parameter in the split, it will split in a space.
and strip it is
Strip is
removing.
removing the empty spaces at left and right side.
Okay.
So
Of
here the
every
error,
word.
the error was this, right? This should be length of number of words.
Okay. So means strip is removing empty spaces on the left and right of every word.
Mhm. No. See here they are. See, it is calling strip on the sentence. So they are stripping. So they are removing spaces in the sentences, because by doing the split, they are already removing the spaces within words, right? So within words, they are already removing the spaces by calling the split.
Okay. And then
But
strip is doing.
let's say strip. Let's say the sentence is like this. There is some sentence, then full stop space. The next sentence starts. So whenever you will be splitting on dot, that space, extra space should be there, right, for the next sentence. So that extra space is getting stripped here actually.
That goes by stripping.
Yeah. So strip means you will remove the, let's say if there is an empty space at the far left and far right, that thing would be removed. Intermediate spaces will not be touched. Okay.
Okay.
That will
That
be
will be
splitted
done
on
by
the
split.
split. Yeah. Yeah.
Okay. Okay, thank you.
So okay, so here we are saying given a file with edges of graph and each line representing an edge in the format node 1, node 2 of the following code attempts to plot a graph based on the data given. Okay, but the code might contain error. Identify the line number corresponding to the error. In absence of the error type, your answer is -1. Okay, so it tries to print the graph. That's it. Okay, that means what? It tries to create the graph first. Okay, then this index dot draw with, if you pass a valid graph, it will plot the graph. Okay, and it, okay, I guess you have seen how it plot the graphs, right, in network x graphs. This is how they plot the graph. Okay, yes. Yeah, so let's see, if I pass a valid graph, it will, based as well as a number the edges, number the nodes and the edges. it will try to create a graph like this. So let's see whether it creates a valid graph or not. G equal to ng.x file, and the format is this: node 1, node 2. Okay. So G, okay, line in file, nodes equal to line.strip.split. So line.strip to remove all the like remaining spaces at the left and right, fine, and strip. So it creates node 1, comma node 2. Yes, until here it is fine. Now nodes 0, it will cause an error, right? Because we cannot cast it to an int because it's a string. Or yeah, if it's a string, or maybe so they have just mentioned node 1, node 2 just to represent it. Actually, they are representing as 1, 2, something like this, 1, 2, 2, 3, something like this. Then it would work. Node 0, node 1, node 2, add the edge, node 1 to node 2, fine. G, nx dot draw with labels equal to true, font weight bold, plt dot show. So see, we haven't add any labels. So with labels, mm,
So the error is
mm,
the variable should not be graph in line 14, it should be G.
but G is not returned. We have not called it. Oh, we have not called it even. So load graph from file has to be called first, right? This graph variable doesn't even exist, right? So this is something silly. I don't think this type of questions will be there. See, this graph variable doesn't exist in the code. That would be the error. Okay, using the idea of from area calculation discussed in the lecture, you are trying to estimate the area of a quarter circle embedded in a square. Identify the line number corresponding to the error if okay. Okay, so you are trying to calculate the area here. Oh, so you are doing what? You are generating a lot of points. Whenever it is within the radius, you mark it as a 1, otherwise mark it as a 0, and then take mean, right? Or take average of that. So 1 divided by total number of draws. The sum of all 1 divided by total number of draws. Fine. So random number of point 10,000, radius 1. So is inside quarter circle y x y, x square plus y square less than equal to r square, x is 0, y is 0. Fine. Mm, x is 0, y is greater than 0. Okay. Estimate the area quarter circle, number of points, radius inside point 0. If number of points random uniformly like generate numbers within the radius, check whether they are within the radius. So plus, do a plus, area is equal to inside points divided by number of points. Estimated area should be area ratio into radius square. Okay. Yeah. So the radius square, why? Because let's say this is 100%. Okay. And let's say the 70% points came within the circle. Okay. Now the area of the square is what? This radius square, and then you take 70% of the total area, which is under the circle. Okay. So this is how much percentage of area or how much fraction of area is within the circle, and then you take the radius square to calculate the whole area, take the ratio on that. Oh, yeah, it's correct. Okay. Select the correct statement corresponding to area calculation using method discussed in the lecture. Okay. The main advantage of this method is that it can handle area calculation given irregular shapes. Yeah. So it doesn't has to be a regular shape like circle or anything. It can create any shape. So the catch is you have to increase the number of sample points. Okay. So the best case scenario is if you treat let's say infinite number of points you can take. So you can kind of think if I take each pixel as a sample point, but those will be computationally heavy, right? Pixels are still fine. So let's infinitesimally means what? It you can take in as much as fraction order I can take in my computer. That would be a lot of computation. So that's why what people usually do, there is a maximum number of points you can draw and you draw them random uniformly. Okay. So it can calculate irregular shapes. The main advantage of the method is that it computationally efficient all scenarios. Yes, the time complexity is always same, fixed number of calls, O of 1. Okay. So no matter how the area is, the number of calls should be always same. Increase the number of random point reduces the impact of random variations and prove more stable. Yes. So how many samples you take, that increase the accuracy of the area calculation. Increasing the number of random points improve the accuracy. Yes. It also reduces. So let's see if I take 3 points, let's say if I take 10 samples, it it would basically increase a noise, right? Random noise in the area calculation. Let's say first time I take 10 random points, second time the random points would change. That would create a noise in the area computation, right? So increasing number of random point reduces the impact of random variations and provides a more stable and accurate area estimation, obviously. So all of them should be correct. But they are saying it is computational efficient for all scenarios. So computational efficiency, um, so whenever you have a regular shape, right? So I guess that's how they reason it. So let's say whenever you have a regular shape, by knowing the dimensions, you can directly compute it, right? You don't have to do 10,000 random samples. So whenever there is a irregular shape, there when you don't have a like existing equation to compute it area, then in that case it is suitable. But all scenarios it is not suitable, right? It's a kind of general method where it can be used in any computation. But let's say you have to calculate area of a circle. You already know the radius. It is not efficient to use this random method. Okay. Select the correct statement regarding IPL library. Correct statement regarding the PL library. Okay. PL stands for Python Image Library. Pillow is the active successor of PIL. Okay. Image.open is used to open images in PIL. Okay. All of the above. Okay. All of the above is. So you can import this image object from PIL and then you can write image.open. And Pillow is basically the PI, like Pillow is PIL library. You installed it like pip install Pillow and then import it like pip import PIL. Okay. Ten. Okay. Okay. Week 10. In the suppose problem, a group of soldiers form a circle
Please
and
home the
it,
screen.
okay. So in a some problem, a group of soldiers form a circle and every kth soldier is terminated until one remains. What would be the output of this code? Third, okay. Hmm. Hmm, hmm, hmm. Again, these things you have to, I guess, run it manually. So n minus 1, n is 25, k is 3. So it will be 24, 3 for the first part. So just, I guess, just unroll it multiple times. At max, it will run 29, 19 times as far as the options are concerned, right? Just quickly run them, add the things up. It will be giving you the spotting. What is the purpose of lower and upper methods in Python when applied to strings? Yeah, lowercase, uppercase anyway. Original string, apple, banana, cherry, apple, date. Modified string, original string dot replace apple with orange. Okay. Modified string. What will the output of the code snippet? Apple, apple. It will only replace the first occurrence. Okay, so here they're saying it will replace both of them. Let's check it once. Mhm. Yeah, okay. It will replace all occurrences. Yes, so let's check it on. S is equal to something and then a something. S dot replace a with b. Yes, it replace everything. Every a with b. Slicing in list works in the same manner as slicing in string. If P is a non-empty list of length n, we wish to create Q that has the first n minus 1 elements in P. What does it say? Slicing in list works in the same manner as slicing in string. If P is a non-empty list of length n, we wish to create a list Q that has the first n minus 1 elements in P. Select the okay, just slice it to n minus 1, right? So n minus 1 will not be in, like, that's excluded, right? The last entry. So this would work. This would also work. This would also work. So all of them should work. Okay. All of them are correct. Select all correct options about matrix given below. So matrix is this. Length of matrix is the number of rows. Yes. Length of matrix 0 is number of column. Yes, because these are rows, right? And these are columns. Dimension of the matrix is 4, 3. Dimension of this is 3, 4. So it is how many rows? 1, 2, 3, 4 rows and 3 columns. So 4 by 3. This is correct. So L is a non-empty list of integers. X is an integer. Okay. Assume that both L and X have already defined the following code does not throw an error when executed. Line 1 and 6 will be used to refer to the state of the variable before and after key section of the code are executed. So before, after, count is 0, L is less greater than 0, L dot remove X, count plus. So it remove all occurrences of X until the whole list is empty. So it basically removes all occurrences of X and return a count. So X is an element of the list at line 1. Line 1, so there is no line number. L has the list. L has at least, so what? Okay, if the value of the count is 10 at the end of the execution of the code, line 6, so this is 6. 1, 2, 3, 4, 5. No. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. Which of the following statements are true? So the value is 10. Okay, so 10 times it removes X. So yeah, at the first line it will be it has a X in the L. L has at least two L has at least two different unequal elements in line 1. This is not correct. Length of L is 10. Yes, length of L is 0 at the sixth line. Yes. So this breaks because it is 0 now. Okay, so that means what it has uh, it actually removed all the x's. It has 10 x's. Okay. it loops 10 times and then it becomes 0. And after 10, so why it becomes 0? Because it has all 10 x's. That's it. Assume that L is an non-empty list of positive integers. Also assume that the list is distinct collection of numbers. That is, no two numbers are alike. Consider the following code. Answers questions 7 and 8 based on this code. S is equal to 0, S x in L, and they are all different. X's are now different. Okay. So S plus 1. Okay. Flag equal to false, y is equal to -1. For x in L, if x times length of L is equal to S. This is actually summing all the elements, right? And what it is checking for each element, if the element times the length of the string is equal to else, return true, y is equal to x and break. So let's say the sum is 30. Okay, and length of the list is 10. Whenever 3 comes, 3 times 10 is equal to 30. So y becomes 3 and flag becomes true. That's it. 7. If the flag is true at the end of the execution of the code below, which of the following statements are true? Note the options should be true for any list L that satisfies the condition given in the common data. Okay, multiple options can be correct. Y is an element in the list. Yes, it should be. Y is the greatest number. No. Y is the average arithmetic mean of the number of the list. Yeah, average arithmetic mean times the length of the total number of total list, right? The length of the list should be equal to the sum, right? So that is correct. Y is an element at length L divided by 2. No, it is not correct. So these two are correct. You get this answer, right? That how arithmetic means time. Arithmetic means time that total length is equal to sum. Assume that L is a list of first n positive integers. Okay, where n greater than 0. So 1 to n. Under what conditions will the variable flag would be true at the end of the execution? Okay, so when it will be true if the number of elements are n. Okay, so what is the minimum number? 1. What is the maximum number? N minus 1. Is it n? No, it is n, right? So the average is what? n plus 1 divided by 2. And when it will be a positive, like, so these are positive integers, right? Integer, so it should not be float. So n plus 1 divided by 2 will be only a integer when n is even. No, sorry, n is odd, right? So it will only be possible if n is an odd number, because the arithmetic mean would then exist within that list. Which numpy function is used to create a matrix of a specific shape with random values between 0 to 1? np.random creates a fixed one floating point value. This rand would create the same. Okay, rand int would create random integers. This and rand n, it creates rand n rand rand n rand n. Let's just see these things. I usually forgot. Okay, numpy as np dot random dot rand. It doesn't, it just takes values from 0 to us. So it rand in what it takes. Rand on in also gives, see, if I give 2 comma 3, it also creates this. So that's these both of them would create. Rand also create the same thing. Rand n would also create the same thing. Okay. Oh, okay. So the value is 0 to 1. I guess we have to read the documentation. Rand n creates. Oh, so it creates a matrices from a normal distribution, not from 0 to 1. Okay, So see, things, this type of questions may come in terms of random also, that the random values should be drawn from a normal distribution. Standard normal distribution, right? Standard normal distribution means the mean should be 0 and the standard deviation should be 1. But here the question is, it draws random values between 0 and 1. In that case, the only np dot random dot rand function would work. Rand n is random normal, okay, and this only rand, this function gives you yeah, uniform distribution over 0 and 1. Okay. Okay, select the correct implementation of a program that creates a text file named pattern.txt with the following contents: age, by, cx. Okay, so it abc, just reverse it. Okay. Okay, the first, what is the code? Open the pattern a b c d, these are the letters. Letter modulo 2, get the middle letter. Okay, and tries to parse the thing from two ways. Okay, so parse the string from 0 to middle and from end to middle, and add the two things. That's it. Okay. Week 11. Selenium library is for crawling, web crawling. So select the correct statement regarding Selenium library. Selenium is a primarily used for web browser automation. Yes, web crawling. The the web driver Selenium interacts with the web browser. The key classes provide set of special keys to be for keyboard interactions. All of them are correct. So by Selenium, you can basically click on a particular element of a web page. Let's say if I want to automate a download, let's say whenever a new movie comes, I want to download it. I can write a code so that it goes to the home page, see the trending movies, click on the trending movie, download it, something like this. Which of the following tasks in WhatsApp can be automated using Selenium? Sending media files, all of them, everything can be automated. Read the given code and identify the correct statement. Statement, okay. Pi tz, do something. Okay, tz all time zone start with Asia. Tz, so it filters out all the time zone that starts with Asia. Okay, so in Asia continent, how many time zones are there? Those will be in the variable. Okay, do something and does something, returns a list of all time zones in Asia. Okay, the our code prints all time zone in Asia. The output of the code can be changed depending on the version of PTZ version used. Why? Because why that is so? This starts with Asia. This nomenclature may have changed, so it can only um, or maybe this all time zones function, this all time zone member may not be present in earlier version of PTZ. Okay. The output of the code can be changed depending on the version of the PTZ version. Okay. So maybe in some earlier version, this Asia, this classification was not there. Asia slash then this type of Singapore, this was not there. Only Singapore was there. Okay. So in that case, this starts with Asia, this would fail. Read the given code, which will be the output of something 20. Okay. Calendar month range. Okay. Calendar dot month range, year comma month. Okay. Return int 1 less than day less than variable 1. What does this month range return? Let's see. year, comma month. One, okay, okay. It gives you valid dates. Valid dates, okay. So variable one less than day, less than yes, less than equal to variable one. So this should be, it should be always true, right? So it can be 1 or 31. This should be true actually. So whichever day you pass, right? That day would be always within the one and the variable one. Variable one means this upper bound. So it will create a truth int you take, it will be a one. It's a mistake, I guess. Read the code, check something. Okay. ER modulo 4 is equal to yeah, it's a leap year, right? Leap year computation. File path, open file path, strip all the files, okay. Take something, sum of months. So it will create the sum of leap year. So 2000, 2004 plus 2, it will be 2. It's 2. Read the given code, calendar something, month 1 to 31 to 12, week of day, year, month 13. Day of week equal to calendar dot Friday, then count. So, so what it does from so so in the
So here,
13th,
in range, so it's 1 to 13. It will
1
consider
to
the last.
1 to 12,
It will
1 to
it
12,
will consider 1 to 12. If it was written in range just 13, then it
then it will
will
start from 0, right? So this 0 is not valid.
okay. Yeah.
So what it will do, it will um, try to find out all the Fridays that are on the 13th day of all the months. Okay, of a particular year. So let's say there are 12 months, right? So whenever there is a Friday on the 13th of all the months, it will count the number of those instances. Now, how am I supposed to know this, right? So if this type of questions are, there is no way of computing this. You cannot possibly know how many uh week. So it's like in the 13th of each month, whether the weekday is a Friday. So like remembering those things are not possible. So anyway, this type of questions will not come, I guess. So you have to run the code, otherwise you cannot do. Read the given code. Count SE, count is equal to 0 for years in range S comma E plus S. Okay, starting year, ending year. Okay, so it counts all the years that are so from 1990 to 2024. It counts all the leap years, and you can just write all them up and count the leap years between them. Okay, so this should be something like 9. In addition to the first birthday celebration, Koreans often celebrate Cyril, okay, which makes the completion of 100th day after 100 day after a baby's birth. This is considered another significant milestone given an input of birth date. Following code tries to compute the date for this. So from birthday, from date of birth to 100th day. Okay. But the code might contains error, identify the number of corresponding errors. Okay. So date time fine. Calculate year, month, day. It will compute from the date of birth to the next 100th day. Okay. So input date time, yes, okay. Date is equal to date plus time delta 99 days. Right? This is wrong. It should be 100 days. The time delta, it should be next 100th day, right? So it should be 100. That's it. Yeah, sixth line is wrong. This should be 100. Read the given code, find the value returned by the find something 2012, find something. First day of the month. Calendar weekday 1. X is equal to first day of the month plus 1 modulo 7. return X. 2012. Okay. So in the 2000, what is the 12th December? First day of the month is what? Let's see. 2000 December first weekday. Friday. Okay. So Friday is uh, Sunday, Monday, Tuesday, Wednesday, Friday. It will be 5. 5. Why? Modulo 7. So Sunday, Monday, Tuesday, Wednesday, Friday. Friday is 5. So I guess the counting starts from 0. Sunday is 0. So 0, 1, 2, 3, 4, and then plus 1, 5, modulo 7. 5. And how I can check this? Calendar dot weekday. Let's see whether it starts from 0. Calendar dot weekday 2000, and let's say the month is 12, date is 1, 4, right? So it's a Friday, it's 4. That means start Sunday is 0. Okay. And 2, see 5, 3, 6, 7, sorry, 1, 2, 3, 3, and then 4. 4 is a 0. So 0 is a Friday. 0 is a Sunday. So day count start from this day count, week of the day start from 0. Okay. 0 to 6
I
basically.
think I think Monday is zero. Monday
Mon
in the lecture they said Monday starts with
let's
zero.
Monday starts with 0. No, Friday is 4, right? So Sunday, Monday, Tuesday, Wednesday, Friday. Sunday is 0.
Sunday is 0 only.
Yes. Calendar, library, Sunday. Uh, very value. Oh, Monday is 1. Okay. So Sunday is 0.
Okay. Yeah.
Now last code, I read the following code. What is the count for 2004 1 return? Calendar count something, year, month, calendar, month range. So it creates for that particular month, first is 1 comma 31, last day is y, okay, count is 0, day in range, day plus last day, so 1 to 31, calendar dot weekday, okay, less than 5 count. So less than 5 means what? 5 is what? 5 is Saturday, right? Saturday. No, less than 5. 4 is Friday, 5 is Saturday, 5 is Friday, Saturday, Sunday is 7. Okay. So, okay, Friday, less than Friday. So Friday, Saturday, these two. So it counts the total number of Fridays and Saturdays. 23. 23. So total number of Fridays and Saturdays it counts for all the months. Okay. So these type of questions will not come as far as I can say, okay, because like knowing or you have to go for a calendar, right? You have to go and check all the Fridays and Saturdays from your phone's calendar, but you cannot bring your phone in the exam hall, right? So these type of questions will not be there, like as far as I can tell. Well, okay, which of the following? Which of the following is not a factor considered in Google's current search algorithm? Page rank is not content relevance, user experience. Yeah, so all of them are considered anyway. In a weighted social network graph, what might be the age represents? Time of the interaction between the user, yes. The strength of the relationship is the number of shared interests. So all of them can be represented by the age weight. Okay, both of them, let's say, like three things. To let's say they like to play video games, uh, eat fish, or something like this. Like there can be multiple intersections among their interests that can be also represented as the age weight. Okay, what is the purpose of a random walk in a graph analysis? Okay, to find the shortest path between two nodes, no. To explore the entries graph and discover its properties, to prioritize nodes based on their degree, no. To determine the central node in the graph, no. So these things we have to do breadth first search or depth first search. So to just discover the locality, we can do a random walk. Okay. Which of the following are real world application of directed graphs? Social media relationship graph? No. Social media relationship graphs are not directed. So because they are so see, whenever a person is connected over social media, like nowadays it is like I can follow them. They might not choose to follow me, right? They are direct. These are directed edges, but most of the time it is like both of them follow each other, right? This social media friendships, so that's why it's a friendship. It's not a follower relationship. If it is a follower relationship, then in that case it can be represented as a direct graph, right? Because I can follow Bill Gates, but he might not follow me. So that's a one directional edge. Okay, but because these are friendships, friendships are always both directional. So directed graphs are not a good suit for that. Family tree, okay, that's correct because we can. So only successors to the predecessor to successor will be a edge, right? So there can be a directed graph for that. Linking of websites, yes, linking of websites. So you can uh, let's say I can hyperlink YouTube's link on my website, but YouTube's might not hyperlink my website's link to their page, right? So that's also a directed relationship. Airline route representation is obviously. So sometimes flight doesn't always come back on the same route. Okay. And think of bridge problem. This I don't know. It's not really. Read the event code, enter the number of in elements in coming coming edges. Okay. Read the number in code, enter the number of elements in coming edges D. Create a weighted directed graph, diagraph, add edge A to B, A to C, and these are the weights B to D, C to D, and D to E. Okay. There is something here. Okay, display incoming edges from node D. So all the incoming edges. What are the incoming edges? The C to D and B to D. These two are incoming edges, and outgoing edges are from D to E. Because see, these incoming outgoing edges are only relevant for directed graphs. Okay. Because for undirected graphs, the incoming edge is also an outgoing edge. Okay. Which of the following statements about page rank is true? It only consider the number of links on their weights. No, all web page starts with the same initial page rank score. Yes, a page rank is the only factor that determines search engine rankings. This is the correct answer. All page ranks, all pages start with the initial same page rank score. Okay. Okay. In the collage sequence, if a starting value is a power of 2, how many iterations are needed to reach the cycle 241? What is a collage sequence? Okay, the Collatz conjecture explains that what happens to sequence defined when the following piecewise definition f is equal to 3n plus 1 colon n is odd, n is odd n, 2 n is even, with n is a positive integer. Okay. Program to print. Okay. See, 1. If n is even, then n equal to n divided by 2. If n is odd, then n equal to 3 times n plus 1. Repeat above until it becomes 1. Okay, so it always end with a 1. Now what was the question? In a Collatz sequence, if the starting value is a power of 2, how many iteration it will need to reach the cycle 4 to 1? Okay. Now it doesn't be logarithmic in size of starting value. Okay. How I can reason that? See. Uh, so there are only two branches, right? Two options that are possible. So at every step, there can be only two options. So two choices. And it's a power of 2, I guess. So no, I cannot reason about this. So why it is logarithmic in terms of the starting value? There are two options obviously, but the like decay are different. So in one direction the decay is more, and the other direction the decay is less. Actually, the one direction the decay, it is not decay, it is actually increasing, right? And in one direction it is decaying. So necessarily it not necessarily reaches this 4 to 1 series. Okay.
It will decay because
Mhm.
it's written it's the power of 2, so it's an
Mhm.
even number.
Divisible, yes. Okay. Okay, so it will only take n divided by 2, that path, right? Okay. So it will not go in this path. It will only decay. Okay. Yes, and it will decay by 2, right? So then in that case you have to go you have to wait for log 2 base n, that much time to reach to this one. Okay. So it's like 64 divided by 2, 32, this sequence. And that's the logarithmic sequences. Got it. Okay. For how many positive integers below 200 does the Collatz sequence does not reach 1? Okay, so there can be odd values where may not reach 1 because they will keep on growing. So how many positive integers below 200 does the Collatz sequence does not reach 1? Does not reach 1. Two Tn plus 1. If n is an odd number, so it's like we have to uh, reach to a odd number, even number, then it will always reach a 1. Okay, so let's say n is an odd number. Okay, odd number times 3 will it be plus 1 would be an even number. Odd even number times 3 will obviously be an even number, right? So even number will be basically divided by 2, so there will be no issue. So every odd number would be converted to an even number at this step, right? So anyway, at the end of the iteration, they will always reach to 1. Okay. Even if you give uh, odd numbers, it will be converted to an even number at the next iteration. Yes, so it will be 0. So there will be always a 1. Which of the following statement is true about Collatz conjecture? It has been proven to be it has been proven to be true for all positive integers. It is known to be false for certain classes of numbers. Okay. it remains an open problem. Its status is unknown. It only applies to prime numbers. No, it applies to all the numbers. Okay. So let's see whether for which number it doesn't work, right? College conjecture, which number does not reach to 1. The conjecture is that these sequences always reach 1 no matter which positive integer is chosen to structure. The conjecture has been shown to hold for all positive integers up to this, but no general proof has been found. Okay, so 2.95 into 10 to the power 20, they have proved it will always reach to 1. Okay, so basically it remains a open problem till now. So there is not a there is no general proof, or there is no inductive proof that okay, if it is true for n, if it is true for n, then it will be always true for n plus 1. This is not been proved yet. Okay, so it's basically trial and error. So they have did trials for up to 2.5 into 10 to the power 20. Okay. Find the number of sequences required for Collatz conjecture when applied to 5 to reach 1. So it's like if it is 5, how many uh, like steps it requires? So 5 times 3 plus 1, that means 15, right? 15 plus 1, no, 16. 16 divided by 2. So what is the sequence? 5. The first entry would be 16. Second entry would be 16 divided by 2, 8. Then 4. Then 2, then 1. So 5. Okay, so we have, yeah, so we have all the, like, exhausted all the weak questions from previous run. Okay, so I hope you will be, so you get the overall idea, right? How the questions are coming from, like, if there will be no coding questions, then you can expect that there will be lot of this reading the program and outputting its uh, expected output, finding out which line has error, uh, and also let's say choose which block, like which code block does what thing, and which code block is correct, which code block is wrong. And these type of things you can expect. Okay. Okay, so fine. The PPT doesn't have all the content. I'll add them if I can. Okay, guys. So good luck for your exam. Stop recording.
Thank you so much.
Okay.